Hello, this is Arshit Mukunda. So today I'm doing the homework 2 of Design and Analysis of Reconfigurable Systems course. So the summary of the homework was to output the 4 MSB of 32-bit up and down counter to 4 LEDs of a DE1-SoC board. So the design will count up or down based on the direction switch. So if we see the board, so this is where we are going to connect the power DC jack, and then this is the USB blaster 2 where we are going to send the file to the board, and then this is the power on or off switch, and then we have about 10 switches over here. So we'll be using the switch 9 as a direction switch. So if it is on towards this side, so which is telling the board that you have to count upwards, so it's up counting, and if it is down, as you can see, then it will be down counting. And then this is the key 0 which we are using as reset button. And then so coming to the quarters, so this is our Verilog code where we are just assigning, and then we are letting know the counter register to count up or down based on the direction in the if else statement. And then we are looking at the last 4 MSBs of the output that will be reflecting on the LEDs, 4 LEDs on the board. So, and then this is the SDC file where I've written this clocking period code, and then this is the test bench which we are going to see on the simulation window waveform. So here, because we will not be able to see the last 4 MSBs on the simulation window, actually because it's going to take a lot of time, so we'll be changing it to the faster one, so which will be easy for us to verify on the simulation application. So we have changed this, and then I click on compilation, so it's going to take some time for compiling, and once it's done we can move on to the next one. So in the meanwhile we'll be doing at this, so we also have to assign the pins for the LEDs. So this is the pin planner assignments for each of the pins. So for this code, we are doing the 4-bit one. So we'll be doing LED 0, LED 1, LED 2, and LED 3, and we'll be putting the IO standard to 3.3 volts by default. And then, so as you can see, I've already got a simulation waveform, which we'll be again getting it. So if you just see at this, so this is the clock, and then this is the reset signal. Once the reset button is high, it starts up counting because the direction is up or direction is high. So it's going from 0, 1, 2, 3, 4 till F. And then once the direction is getting low, so because in it's interfering the up counting second cycle after it's 2, so it starts down counting from that position. So it's going from 1, 0, and then it starts down counting from F till the 0. So and then, so this is just the verification text for this waveform. Then this is what I've got the report, which we'll be seeing again after the compilation report is ready. So this part of code used 17 ALMs, and then the maximum frequency is 390.78. So let us see this. Yeah, so this compilation is ready. So if you just see this filter summary, so here it says the ALMs used is 5, but if you just remember, we just changed this to 7:4. I'll again show it to you once I rechange it to 31 to 28, which is the 4 MSB bits which we desire to see on the board. That will be 17. So once this is done, we'll just look at the pin planner. So this is these are the LEDs count 0, count 1, count 2, count 3 as cross verified with the document that I've received, and then we'll run the simulation. So it's still loading. Yeah, I guess it's ready. So if you just see at this is what we wanted at the output. So if you just cross verify 0, 1, 2, 3, 4, 5 till F, and then this is started up counting in the second cycle. So it's 0, 1, 2, but the direction pin has changed to down counting, or direction pin has gone low. So it starts down counting from this position. So it goes from 1, 0, F, and then till 0. So this was the reason why we changed the assign bits to 7 to 4, so that it would be easy. But if we have 31 to 28, we will not be able to see the waveforms this clearly. So and then let us change this back to 31 to 28. So this is our MSBs which we want to which is desired to see on the DE1-SoC board. So this is still loading. And then our report also asked for changing the number of bits to last 10 MSBs. So we all, and again we have the pin assignments for that from the data sheet. So basically we are just changing the registers, and then we are increasing the width of the wire or the count variable from 4 to 10, and then we are just changing this to 31 to 22, which is 10 bits. So it's still compiling. Okay, yeah, the compilation is ready. So if you just see at this footer, so you can see that the logic utilization in ALMs is 17, which is what we are using. So this is lesser because we are using just the 4 MSBs on the board. So yeah, so the next step would be looking at the pin planner, which we have already looked at. So again, these are the same thing that we are supposed to assign according to the data sheets. And then we'll start with the programming it to the board. So because I wanted to show the LEDs on the board, I'm recording it using my mobile. So we'll just start with programming. So we have to select the hardware, so which is already done, and mode is JTAG, and then we usually start with auto detect, so it can detect the connections. So this is the output LED counter 5 that we are going to send it through the JTAG to the board. So we have to check this and then we just click it on start. So here it says the progress is 100% successful. So if you just look at this, you can see that this is on the upper side, so it is up counting, and then we'll just click on reset so that we can see the cycle. So it's 0 0 0 0 1 0 0 1 0 0 0 1 1. So it starts up counting till all the LEDs are high, which is F. That's 0 1 1 0 and then 0 1 1 1. So now it's 1 0 0 0. 1 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 and then 1 1 0 1 and then 1 1 1 0 then 1 1 1 1. So this is the F, and then it's again going to start with 0. So our LED is going to go low and then 0 0 0 1. So now we are going to push the direction to the lower side, so it says I want you to down count it. So if you just see, it's going F, E, and so on, and it will go till all the LEDs are going low. So this was the first part of the second homework, where we do the 4 MSB's LED blinking. So this is the up counting and down counting. Yeah.